And Microsoft just proved that in AI, raw size doesn't always win. Forget trillion-parameter behemoths, because Microsoft just built a math model that outperforms giants literally hundreds of times larger. And here's the kicker. It was trained in just 1 week on only 64 GPUs. Yeah, you heard that right. But that's not all. They also dropped 2 brand new in-house models. One is a voice AI that can spin out a full minute of natural audio in under a second, and the other is their first foundation language model, trained on a jaw-dropping 15,000 H100 GPUs, now beginning to roll out inside Copilot. This is a turning point in AI development, so let's break down why this matters and what it means for the future. The problem with chain of thought. All right, let's start with Microsoft's new RStar 2 agent. You've probably heard of chain of thought reasoning before. That's when large language models solve problems step by step, stretching out their logic kind of like writing a long explanation on paper. The idea is simple. If the model just thinks a little longer, it's more likely to catch its mistakes and get the right answer. The problem? That doesn't always work. If the model makes a mistake early on, it usually just doubles down, confidently walking you through an entire solution built on a wrong first step. It's like watching someone solve a math problem. They write everything neatly, but a tiny error in step 1 means the entire solution collapses. Microsoft's researchers looked at this and said, okay, longer chains aren't enough. So instead of just making the model think harder, what if we gave it tools? Let it check its own work and adjust as it goes. That's where RStar 2 agent flips the script. Unlike typical models that just spit out text, RStar 2 uses agentic reinforcement learning to interact directly with a Python environment while reasoning. Think of it like giving the model access to a calculator, a sandbox, and a notebook all in one. When it faces a math problem, it can stop, write some code, run it, check the result, and then decide if it's on track. If the numbers don't add up, it pivots, fixes its approach, and tries again. That dynamic back and forth makes it far more reliable because it's not locked into one rigid way of thinking. But to train something like this, Microsoft had to deal with a huge challenge, handling tens of thousands of code executions happening simultaneously. If you naively run that, GPUs just sit idle, waiting for results, and everything slows to a crawl. So the team engineered a custom infrastructure, a distributed code execution system that can handle 45,000 tool calls at once with sub-second latency, isolation between code execution and training while balancing loads across CPU workers, and a dynamic rollout system that assigns GPU tasks based on real-time cache availability, making sure no GPU sits idle while others are overloaded. The end result? They trained a frontier-level model in just 1 week on 64 AMD MI300X GPUs. That's insane efficiency compared to the monster clusters we're used to seeing. Now, the real magic wasn't just the hardware. It was the algorithm, Group Relative Policy Optimization with Resampling on Correct, or GRPOC. Here's why that matters. In traditional reinforcement learning, a model gets rewarded if it lands on the right final answer, even if its reasoning was messy. That teaches brute force instead of clean logic. GRPOC flips that idea. It oversamples initial attempts, filters out noisy traces, and rewards the ones where the tool usage was efficient and the reasoning was clean. The model still sees failed attempts because learning from mistakes is essential, but the positive reinforcement comes from high-quality reasoning traces. Over time, this makes the model not just accurate, but efficient in how it reasons. And Microsoft trained it in stages. Stage 1. No reasoning allowed. just learning to follow instructions and format tool calls correctly. This alone pushed benchmark accuracy from nearly 0 to 70%. Stage 2. Expanded reasoning window to 12,000 tokens, letting the model handle more complexity. Stage 3. Filtered out all the easy problems, so the model only trained on the toughest ones. That constant pressure kept it improving instead of plateauing. The payoff? On the AME24 benchmark, RStar 2 scored 80.6% accuracy. On AME25, it hit 69.8%. To put that in perspective, it outperformed DeepSeek R1, a massive 671 billion parameter model. And it did this with fewer reasoning tokens, about 10,000 on average versus over 17,000 for other models. That efficiency carried over beyond math. Even though it was only trained on math problems, it transferred well to scientific reasoning and stayed solid on alignment benchmarks. That means it isn't just memorizing math tricks, it's showing adaptable intelligence. Inside, researchers even spotted something new. Reflection tokens. These popped up when the model analyzed tool feedback, like checking Python output and adjusting strategy. That's a sign of environment-driven reasoning, not just internal logic. That's a huge leap beyond chain-of-thought reasoning. But math wasn't the only thing Microsoft dropped. Meet MAI Voice 1. This is their new speech generation model, and it's shockingly fast. It can generate 1 full minute of high-quality, natural audio in less than 1 second, and it only needs a single GPU to do it. That opens the door for all kinds of applications. Interactive assistance, podcast narration, even real-time voice in consumer devices. Because it runs on just 1 GPU, it's actually feasible outside massive server farms. It's multilingual, handles single or multiple speakers, and it's already sneaking into Microsoft products. If you've gotten a Copilot voice summary lately, you may have already heard it in action. And then there's MAI-1 Preview. This is Microsoft's first end-to-end foundation language model, completely built in-house. Until now, Microsoft leaned heavily on partners like OpenAI. But this one? It's theirs. Trained on a 15,000 H100 GPU cluster using a mixture of experts architecture, it's optimized not for raw power, but for consumer use cases. Think writing emails, summarizing text, helping with assignments, and casual Conda. It's already live on the Elmar Arena platform, and Microsoft is rolling it into Copilot gradually, starting with text scenarios and gathering feedback before a broader rollout. This isn't a flashy drop and forget. It's a long-term play to make sure their foundation models are not just powerful, but practical. Microsoft is showing that efficiency, adaptability, and practicality are now just as important as scale. RStar 2 proves that smaller, smarter models can beat out massive ones if you train them the right way. MAI Voice 1 shows speech AI can finally hit real-time consumer use. And MAI-1 Preview signals Microsoft is serious about building its own foundation layer for the future of Copilot and beyond. It's a bold move, and it changes the game. If you found this breakdown as fascinating as I did, don't forget to hit like, drop a comment, and subscribe for more deep dives into AI's next frontier. Thanks for watching. See you in the next one.